Good morning and welcome to our live coverage of the rollout of the United Launch Alliance Atlas V rocket this morning here at Cape Canaveral. You're looking at a live view of, on the left, Space Launch Complex 41 at Cape Canaveral Space Force Station. On the right, about a third of a mile to the south of Complex 41 is ULA's Vertical Integration Facility, where the Atlas V rocket is set to emerge momentarily to begin its roll to the launch pad in preparation for liftoff tomorrow afternoon. And now, just outside the door of the Vertical Integration Facility, the Atlas V is now emerging. The Atlas V rocket is mounted to its mobile launch table for the ride to the launch pad this morning. The Atlas V was stacked onto its mobile launch platform over the last month or so. That stacking process began back on December the 18th with the lifting of the Atlas V's first stage segment, followed by the integration of a single solid rocket booster to the side of the first stage. And then on December 23rd, the upper stage, the Centaur upper stage, was attached on top of the first stage. And then earlier this month, about a week and a half ago, on January 10th, the payload fairing was rolled out to the launch pad from a nearby clean room processing facility and hoisted atop the rocket. This Atlas V stands 196 feet tall, and it's set to carry a pair of satellites into orbit for the U.S. Space Force. This mission will carry the fifth and sixth satellites for the Space Force's Geosynchronous Space Situational Awareness Program, also known as GSAP. These GSAP satellites, GSAP 5 and 6, were built by Northrop Grumman, carrying optical sensors to track objects and space debris and other satellites in the geosynchronous arc. Geosynchronous orbit being a popular location for communication satellites and other spacecraft, both in the commercial and military sectors for the U.S. and for foreign governments. As with most rollouts of Atlas V rockets, the rocket usually emerges from the vertical integration facility. It'll pause for a little bit as ULA teams check the alignment of the rocket, and then it'll continue for that journey out to Pad 41. Again, the vertical integration facility, also known as the VIF, stands about 300 feet tall, 293 feet tall to be exact, and is positioned about 1/3 of a mile south of Pad 41, which is the Atlas V's launch pad here at Cape Canaveral. This will be the 91st flight of an Atlas V rocket since its debut back in August of 2002, and the first Atlas V mission of 2022. Again, it looks like that rollout has paused as expected, just outside the doors to the VIF. The Atlas V in this configuration stands 196 feet tall, and on top of that rocket are two U.S. Space Force surveillance satellites bound for geosynchronous orbit. This mission is designated by the Space Force as USSF 8, United States Space Force Mission 8. And the payloads on board are the GSSAP 5 and 6 spacecraft heading for geosynchronous orbit. Launch tomorrow is scheduled for 2 p.m. Eastern Time, or 1900 UTC. And this rollout is a key step to prepare for that. The rocket was assembled inside the vertical integration facility over the last month, and it'll spend the rest of its time leading up to launch on the pad at Complex 41. Once at the pad, ULA teams will prepare the rocket for fueling. In fact, it's expected that kerosene fuel, which is kept at room temperature roughly, will be loaded into the first stage later this afternoon. And then the rocket will be secured overnight, and the countdown will begin tomorrow morning, shortly after dawn here on the Space Coast, leading up to the start of cryogenic tanking with liquid hydrogen and liquid oxygen, the rocket's other propellants, at around midday, leading again to liftoff time targeted for 2 p.m. The Atlas V is now resuming its motion out toward the pad. At this time, the rocket is on the move again. This rollout should take anywhere between 30 minutes to 1 hour. And it'll culminate by arriving at the pad the mobile launch platform is being pushed by trackmobile devices along dual rail tracks. for this journey. And those devices are accompanied by ground equipment that keeps critical parts of the launch vehicle, as well as the payload compartment on top at the proper temperatures, the proper humidities, and the safe conditions to ensure those two satellites on top of the Atlas V remain in good health in preparation for launch tomorrow. The Atlas V is just passing or just past the halfway point in this rollout. Again, about a third of a mile of distance being covered this morning by the Atlas V on its mobile launch platform. Trackmobiles are pushing the mobile launch platform like locomotives along rail tracks that line the pathway between the Vertical Integration Facility and Space Launch Complex 41. So this mission is carrying two more satellites for the Space Force's Geosynchronous Space Situational Awareness Program, or GSAP. So these satellites designated GSAP 5 and 6, and there on the upper right of your screen you can see an artist's illustration of these two satellites built by Northrop Grumman. These will join four others that were launched on a pair of Delta IV rockets by ULA back in 2014 and 2016, this being the fifth and sixth of the fleet. The GSAP satellites are designed to operate in geosynchronous orbit, as the name might suggest. Geosynchronous orbit is located around 22,000 miles or 36,000 kilometers over the equator, and it's just the right altitude for a satellite's orbital velocity to match up with the rate of Earth's rotation. So it allows satellites to remain essentially hovering over a fixed geographic region of the planet. And this makes it popular for use by a lot of military satellites and communication satellites. The GSAP satellites are fitted with optical sensors to search for and detect and characterize other objects in geosynchronous orbit. This assists the Space Force's capability to catalog and track space junk and satellites in near-Earth space. Not only are the GSAP satellites capable of detecting satellites and space junk from afar, they also have a capability for rendezvous and proximity operations, meaning they can approach interesting objects or satellites that the Space Force wants to look at or interrogate. A great view here of the Atlas V. You can see the motion as it slowly crawls toward pad 41 at Cape Canaveral Space Force Station. Approaching this pad, the launch complex there includes those four lightning towers, those four lightning masts on either side of the launch mount. Offers some protection against lightning and thunderstorms that are fairly common here in Central Florida. At the very center of the lightning mast, you can see a small vertical rise or vertical structure. That's the housing at the launch pad that allows the mobile launch platform to connect up with the ground electrical, ground propellant supplies, and essentially connect up to hoses that route fuel into the rocket during the countdown. Just to the left of that, in between those lightning masts, is the crew access tower, which was constructed a few years ago to provide access to the rocket for astronauts who will fly on Boeing's Starliner crew capsule in the future. And then off to the left, the white spherical ball, you see the top half of that above the brush. That's the liquid oxygen tank, ground storage tank that contains oxidizer that will be loaded into the Atlas V first and second stages during the countdown tomorrow. The Atlas V is now entering the launch pad area. passing those two lightning towers on the south side of the pad on the right side of your screen. The rollout typically slows at this point as the ground team ensures proper alignment for the launch vehicle as it approaches the pad and the launch mount. So it looks like the motion is paused here, a typical stopping point as the rocket nears the launch pad. The Atlas V rocket is on the move once again as it slowly crawls the final segment of its journey toward Pad 41, now inside the perimeter of those 4 lightning towers on the pad. This particular launch vehicle is designated the 511 configuration, and here you see an artist's illustration, a chart showing the various configurations that ULA's Atlas V rocket comes in. So this will be the 91st flight of an Atlas V rocket overall, but just the first flight of the 511, and the 511 is the only configuration of this fleet that is yet to fly. So this particular mission will debut a new configuration for the Atlas V. The Atlas V configurations are sized to meet different customer demands, with on the left side of the screen here, the 401 being the lightest and lowest thrust, lowest performance of the group, and also the least expensive. And then on the far right, the heaviest is the 551, which has launched missions such as the New Horizons probe to Pluto back in 2006. So today, the 511 roughly is one of the lower thrust configurations of the Atlas V, but it needs that 5-meter fairing in order to contain the Centaur upper stage during its flight into space, and then the Centaur will deploy from the first stage a few minutes after launch and perform a series of burns to place the 2 geosynchronous space surveillance satellites into orbit for the U.S. Space Force. The rollout officially began at 10:12 a.m. Eastern Time, or 15:12 UTC, according to United Launch Alliance. So now about 35 minutes into this rollout. As we said at the start of our stream, the start of our coverage, the rollout of an Atlas V typically takes 30 minutes to 1 hour. So we're 35 minutes in, and the Atlas V is nearing Pad 41, nearing the launch mount, not quite there. As I mentioned a moment ago, this is the Atlas V, Atlas V's first launch in the so-called 511 or 511 configuration. Just a note of nomenclature: the 511 number, the meaning behind that, the 5 is a indication that this mission will use the 5-meter version of the Atlas V's payload fairing, built by a company called Ruag Space in Switzerland. On the right side, you can see a cutaway view cutaway exploded view of the Atlas V. The payload fairing near the top of the rocket encloses the rocket's Centaur upper stage, which will do the burns necessary to place those 2 satellites on the very top of the rocket into geosynchronous orbit, more than 22,000 miles or nearly 36,000 kilometers over the equator. In order to reach that orbit, the Centaur upper stage will perform 3 burns with its Aerojet Rocketdyne RL-10 engine. Those burns, the first of those burns will place the satellites into a parking orbit around 13 minutes after launch, and then 2 additional burns, one about an hour and 9 minutes after liftoff, and then another about 6.5 hours after liftoff will do the final orbit adjustments needed to inject these two satellites into geosynchronous orbit. This is a rather long mission for ULA, the length stretching 6 hours and 45 minutes from the time of liftoff until the separation of the second of these two GSAP, Space Force Geosynchronous Surveillance Satellites. Also in this cutaway, you can see below the payload compartment the boat tail structure positioned beneath the payload fairing to taper the diameter of the rocket down to from the wider diameter of the payload fairing to the more narrow first stage. That first stage is the bronze part of the rocket, containing two tanks, one for RP1, which is a rocket-grade kerosene fuel, another for liquid oxygen, which will be consumed by the RD-180 engine at the bottom of the rocket for its 4+ minute burn to begin the launch tomorrow afternoon. And then on the left side of that rocket, the single solid rocket booster is illustrated in this view. As you can see, the Atlas V rocket is very near the launch mount out at Pad 41 here at Cape Canaveral, Florida. Just perhaps a few more feet to go. We'll wait for confirmation from United Launch Alliance uh, officially that the rollout is complete. However, it does look like there's just a few feet to go to position the Atlas V right over the flame bucket out at pad 41. So we'll stand by for that final confirmation. Again, two locomotives are pushing the Atlas V along rail tracks for this journey. The journey began at 10:12 a.m. Eastern Time from the vertical integration facility, the structure visible at the right of this view. So the launch vehicle has covered about a third of a mile, or 1,800 feet or so, throughout this rollout over the last 40 minutes or so. In this view, you're looking live at Complex 41 at Cape Canaveral Space Force Station in Florida. The Atlas V inching toward its final position for today's rollout, inching toward its starting point for launch tomorrow afternoon. Liftoff is targeted for 2 p.m. Eastern Standard Time, or 1900 UTC tomorrow. In this view, you can see the Atlas V nearing its launch position. Just to the left of the rocket is the crew access tower, which will be used for future crew missions using the Atlas V rocket. Those missions will utilize a Boeing's Starliner crew capsule, and this access tower was erected over the last few years to ready for these human launches on the Atlas V. At the top of that tower is an access arm and a white room that will connect up with the hatch on the Boeing Starliner spacecraft. Those four towers, two on each side of the crew access tower. Those four masts are lightning towers designed to protect rockets from lightning while they're on the pad. They're linked up by a set of catenary wires that might be visible near the top of those masts, connecting each one of those towers to each other. On the left side of the pad, near the ground level, you can see the top half of the liquid oxygen storage sphere. This is a ground tank containing a super cold oxidizer that will be loaded into the Atlas V tomorrow. The launch pad also has a set of liquid hydrogen and RP1 kerosene tanks, not visible in this view, that will also be used to pump propellants into the rocket in preparation for liftoff tomorrow. On top of the rocket are a pair of U.S. Space Force satellites. These satellites are part of the Geosynchronous Space Situational Awareness Program, known by the acronym GSSAP, pronounced GSAP. These GSAP satellites provide sort of a neighborhood watch capability for the military in geosynchronous orbit around 22,000 miles or 36,000 kilometers over the equator. The satellites are mounted together in tandem inside the payload fairing of the Atlas V, and they'll deploy from the top of the Centaur upper stage around 6.5 hours after launch tomorrow. This is an artist's illustration of the two GSAP satellites as they will appear in geosynchronous orbit with their solar panels deployed. They carry sensors to detect and track objects in geosynchronous orbit, objects like satellites and space junk, and they also have a rendezvous and proximity operations capability, meaning they can approach the vicinity of other satellites in geosynchronous orbit to allow for inspections and characterization. So the Atlas V is very near the launch mount. It may just be in position at this point, or it may just have a few feet to go. We'll wait for confirmation from ULA that the rollout is complete, and we'll let you know when we receive that information. you're just joining us, you're looking at a live view of Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida, where an Atlas V rocket has just about completed its rollout from the vertical integration facility. In this view on the right side, you can see the structure, the vertical integration facility, where the Atlas V rocket was assembled over the last month, beginning with stacking of the first stage of the Atlas V rocket on its mobile launch platform back on December the 18th. That was followed by the addition of a single solid rocket booster, and then the hoisting of the Centaur upper stage on top of the first stage of the Atlas V on December 23rd. And then after the holidays, ULA's technicians returned and stacked the payload fairing of the Atlas V rocket on January 10th, completing the buildup of this Atlas V launch vehicle to its full height of 196 feet. Or about 60 meters. And then this morning at 10:12 a.m. Eastern Time, or 15:12 UTC, ULA began transferring the Atlas V from the vertical integration facility to Space Launch Complex 41. The rocket covered a distance of about a third of a mile, or 1,800 feet, in a little less than an hour, riding its mobile launch platform, which itself was pushed by locomotives or trackmobiles along a path of dual tracks leading in between the VIF and Space Launch Complex 41. And now you can see the Atlas V rocket is in position. Right now, ULA's ground crew is securing the rocket to its launch position out at Pad 41 before officially declaring the rollout complete. This mission is scheduled for launch at 2 p.m. Eastern Standard Time, or 1900 UTC tomorrow, Friday, January 21st. It's carrying a pair of United States Space Force satellites into space. These two satellites are part of the Geosynchronous Space Situational Awareness Program, or GSSAP program, which are designed to detect and track and characterize satellites and space debris in geosynchronous orbit. Geosynchronous orbit is a regime about 22,000 miles, or nearly 36,000 kilometers over the equator, a popular area for communication satellites, as well as numerous U.S. and Russian and Chinese military satellites as well. This artist's illustrations shows the GSAP 5 and 6 satellites as they will appear in space with their solar rays extended. These two satellites are stacked inside the payload fairing of the Atlas V rocket. And these two spacecraft were manufactured by Northrop Grumman for the U.S. Space Force. These two satellites will join GSAPs 1 and 2, which were launched on a Delta IV rocket back in 2014. And GSAPs 3 and 4 were also launched on a Delta IV rocket from Cape Canaveral in 2016. The Space Force announced in 2017 they were going to order 2 additional GSAP satellites, 5 and 6, and those are the spacecraft on top of the Atlas V rocket, now on Pad 41, awaiting liftoff tomorrow afternoon. You're looking at a live view of United Launch Alliance's Atlas V rocket on Pad 41 at Cape Canaveral Space Force Station in Florida. A couple of minutes ago, ULA confirmed that the rollout of the Atlas V rocket was completed. ULA marked the completion of the rollout at 11:19 a.m. Eastern Time, or 16:19 UTC. Rollout began at 10:12 a.m. Eastern Time this morning from the Vertical Integration Facility. The Vertical Integration Facility is the structure standing about 300 feet tall on the right side of this view. The Atlas V emerged from that building shortly after 10:12 a.m. Eastern Time to begin its journey out to Pad 41. That distance from the VIF on the right to Pad 41 on the left took about an hour, covered a third of a mile, or 1,800 feet. The Atlas V rode for that journey on a mobile launch platform, which itself was pushed by locomotives or trackmobiles riding along dual rail tracks that are laid along the path from the Vertical Integration Facility to Pad 41. Those trackmobiles were accompanied by ground equipment to ensure all the proper purges were continuous and in place for the Atlas V rocket and its payload compartment to ensure that all the components on board remained at the proper temperatures and proper humidity levels to remain safe and healthy for tomorrow's launch. Now that the rocket is at the pad, ground teams are beginning the process to secure the Atlas V and its mobile launch platform to various connections at the pad. Those connections will feed pneumatic lines as well as propellant lines leading to the Atlas V from the ground supplies. Those propellant lines will include connectors, autocouplers that engage to feed RP1 kerosene into the Atlas V rocket, as well as super cold liquid hydrogen and liquid oxygen. Later this afternoon, if all goes according to plan, ULA plans to load around 25,000 gallons of RP1 fuel. This is a highly refined rocket-grade kerosene. That kerosene will be loaded into the tank on stage 1 of the Atlas V this afternoon. Kerosene is stored at room temperature, meaning it can be loaded into the rocket and remain there for long periods of time, whereas the other propellants used by the Atlas V, liquid hydrogen and liquid oxygen, are cryogenic fluids, meaning they have to be chilled to several hundred degrees below zero. And those won't be loaded until the final 2 hours of the countdown tomorrow, because those cryogenic propellants will boil off in the warm ambient temperatures here on Florida's Space Coast. So liftoff tomorrow is scheduled for 2 p.m. Eastern Standard Time, or 1900 UTC. The satellites on board are 2 spacecraft for the U.S. Space Force's Geosynchronous Space Situational Awareness Program, or GSSAP. These 2 satellites are fitted with optical sensors to detect, track, and characterize other satellites, as well as space debris objects in geosynchronous orbit around 22,000 miles or 36,000 kilometers over the equator. These satellites will be the 5th and 6th spacecraft to join the GSAP fleet. The weather forecast for tomorrow calls for a 70% chance of acceptable conditions. The primary weather concerns tomorrow are associated with the cumulus cloud and thick cloud layers. However, during the window tomorrow, the 45th Weather Squadron predicts, again, a 70% chance of good weather with partly to mostly cloudy skies, temperatures from the north of around 5 to 9 knots, and a temperature tomorrow afternoon around 73 degrees Fahrenheit and a humidity of 68%, with no visibility concerns tomorrow afternoon. ULA does have a backup launch opportunity available on Saturday. For that opportunity, the 45th Weather Squadron here at Cape Canaveral predicts a 60% chance of good weather, so slightly lower odds of good weather on the backup day Saturday if needed. This will be the fourth launch of the year from Cape Canaveral tomorrow, following 3 consecutive missions performed by SpaceX's Falcon 9 rocket family on January 6th, on January 13th, and also January 18th earlier this week. This will be ULA's first launch of the year, and again, it will be the 91st launch of an Atlas V rocket overall. Now 26 hours and 28 minutes until liftoff time tomorrow. We thank you for joining us for our live coverage this morning of the Atlas V rocket's move from the vertical integration facility out to its launch pad here at Cape Canaveral, Florida. We'll have live coverage of the final hours of the Atlas V's countdown tomorrow. We're planning to begin our coverage at 11:30 a.m. Eastern Time or 16:30 UTC, just prior to the start of cryogenic tanking during the countdown tomorrow, leading up to liftoff time at 2 p.m. Eastern Standard Time or 1900 UTC. So we will hope you join us tomorrow for our live Atlas V launch coverage. Until then, I'm Stephen Clark at Cape Canaveral, and thanks for joining us.